So chapter 5.2, there's two topics here to cover. First, we're going to talk about scientific notation, and then we're going to talk about rational exponents. So a scientific number, or a definition of scientific notation, scientific notation are numbers expressed in the format n times 10 to the power p, where n is a number between 1 to 10, so examples of scientific notation can be 2.615 times 10 to the power 25, which is a really large number, or 1.99961 times 10 to the power negative 11, which is a really small number. The rule is that if we move forward subtract from p and backwards add to p. So for example, if I've got 26.15 times 10 to the power 24, because 26.5 is not a number between 1 to 10, we have to convert this to scientific notation by moving the decimal point 1 backwards. That means we add 1 to the power of 10. So 2.615 is a number between 1 to 10, and we add 1 to the 24 and make it 25. If we have 0.2615 times 10 to the power 26, we have to move forward one place to get this to be a number between 1 to 10. So this is 2.615 times, and then we subtract 1 from the power to make it 10 to the power 25. So if I've got, say, 0.1 1663, and I wanted to convert this to scientific notation. To get to that number between 1 to 10, I would have to move the decimal point one place forward. Now, think about this before we do anything here. Remember that 10 to the power 0 is equal to 1. So this is 0.1663 times 10 to the power 0. And if I move that decimal place one place forward, the decimal point one place forward, it becomes 1.663, which is a number between 1 and 10. And I subtract 1 from the power 0, and I get negative 1. If I've got 0.0000045, this is 0.0000045 times 10 to the power 0, which is equal to, now I have to move this 5 places forward. That means I need to subtract 5 from the power of 10. So this is 4.5 times 10 to the power negative 5. If I have 123 million, I need to move, there's a decimal point at the end, so I would need to move back 8 places to get to a number between 1 and 10, which is 1.23. And because I move backwards 8 places, I add 8 to the power 0, so 10 to the power 8. If I wanted to write 4.632 in scientific notation, since 4.632 is a number between 1 and 10, I would simply write 4.632 times 10 to the power 0. If I wanted to convert backwards from scientific to standard form, 1.95 times 10 to the power 5 means I would have to reverse the process and go 5 places forward to get the number. So I would add in 1, 2, 3 zeros and move my decimal 5 places forward. So this number is actually 195,000. Or if I wanted to express 1.86 times 10 to the power negative 4 as a standard number, I would start with 1.86, and I would need to move backwards 4 places. So move the decimal point backwards 4 places, so this 0.000186. To add or subtract scientific notation, one, the exponents or powers of 10 must be made the same. Add or subtract with only the same power. Simplify if necessary. So let's look at a few examples here. If I'm asked to add 3.3 times 10 to the power negative 16 plus 7.5 times 10 to the power negative 16, I would, since the powers are already the same, all I would need to do is add the numbers 3.3 plus 7.5 and keep the same power negative 16. So this is 5 and 3, 8. So this is 10.8 times 10 to the power negative 16. So now we can see that 10.8 is not a number between 1 and 10. So we have to take the decimal one place backwards to give 1.08. And when we take that decimal one backwards, we add 1 to the power. So that becomes 1.08 times 10 to the power negative 15. So more examples. I have 9.2 times 10 to the power negative 50 plus 2.6 times 10 to the power negative 51. So notice now that my powers are not the same. I either make them both 50 or both 51. So 9.2 times 10 to the power negative 50, 10 to the power negative 50. And if I move it, the decimal point one place back, it becomes 0.26, and add 1 to the power, 10 to the power negative 50. So now all I would need to do is add 9.2 plus 0.26 times 10 to the power negative 50, which is 9.46 times 10 to the power negative 50. So if I wanted to subtract 2.3 times 10 to the power negative 4 minus 3.6 times 10 to the power negative 5. Since the powers are not the same, I'm going to make the negative power, 5 power negative 4 and see if that will work for me. So the 2.3 times 10 to the power negative 4 minus, and if I move back one place, it becomes 0.36 times 10 to the power negative 4. Then I would take 2.3 minus 0.36 times 10 to the power negative 4, which is 7.04 times 10 to the power negative 4. One final example for adding and subtracting. I have, say, 9.2 times 10 to the power 50 plus 2.6 times 10 to the power 51. So I'm going to make this the power 51 by moving one place forward, one place backwards and adding 1 to the power, so 0.92 times 10 to the power 51. Okay, if I move one place backwards, plus 2.6 times 10 to the power 51. So 2.6 plus 0.92 times 10 to the power 51 is equal to 2.6 plus 0.92 is 3.52 times 10 to the power 51. I just wanted to point out that if you have your own calculator, you can do this very simply with the calculator. You would have to go ahead and press mode, look at the key press history, and then when it says normal, move it over to scientific and press enter, and then press the clear button. This puts the calculator in the scientific notation mode. So if I have 0.000562 and I press enter, this tells me it is 5.62 times 10 to the power negative 4. The E here means 10. Or if I have 1236000 and I pressed enter, this is 1.236 times 10 to the power positive 6. If I wanted to add two numbers, 9.2 times, always use parentheses for the scientific notation, so 9.2 times 10 to the power, I'm doing that example that we just did, negative 50 plus, open parenthesis, 2.6 times 10 to the power negative 51, and close the parenthesis and press enter, and it gives us the answer as 9.46 times 10 to the power 50, which is the answer that we had for the problem right here. So yes, if you have your own calculator, you can experiment with that a little bit. Now going back to multiplying and dividing scientific notation, to multiply or divide scientific notation, comma, multiply or divide n add or subtract the power of 10. For example, if I have 3.1 times 10 to the power 16, what is wrong? Times 2.7 times 10 to the power 32. I would simply multiply 3.1 times 2.7 and add the powers, 16 plus 32. So 3.1 times 2.7 is 8.37 times 10 to the power, that is 6 and 2, 8, 4, 3 and 1, 4, so 10 to the power 48. One more example, 8.4 times 10 to the power negative 2 times 7.7 times 10 to the power negative 45. So this is 8.4 times 7.7 multiplied by 10 to the power negative 2 plus negative 45. 8.4 times 7.7 is 64.68 times 10 to the power negative 47. But 64.868 is not a number between 1 to 10, so we would have to go backwards one decimal place, to make it 6.468. And if we go backwards, we add 1 to the power. So negative 47 plus 1 is negative 46. So this becomes negative 46 here. And again, if you have a calculator that does this, you can actually use the calculator to multiply. Here I go, 8.4 times 10 to the power negative 2, 7.7 times 10 to the power negative 45. And this will give you the answer straightway as 6.468 times 10 to the power 46. I might have, say, 3.1, oh, clear, 3.1 times 10 to the power 32 times 7.68 times 10 to the power negative 45. So we would be adding an 32 plus negative 45 and carrying one decimal place to give an answer of 2.303808 times 10 to the power negative 12. Now a couple of examples with dividing. So 1.092 times 10 to the power 51, 9.1 times 10 to the power 13. So I would divide 1.092 divide by 9.1 and subtract the powers this time. 10, 51 minus 13. So this gives me 0.12 times 10 to the power 38. But 0.12 is not a number between 1 to 10, so I would have to go forward one decimal place to make it 1.2. And if I go forward, I would have to subtract 1 from the power. 10 to the power 37. 8.7 times 10 to the power 3 over 1.4 times 10 to the power 4. 8.7 over 1.4 times 10, 3 minus 4. 8.7 divided by 1.4 is 6.214 times 10 to the power negative 1. And I'm just going to do one quick example to show you how you can divide with the calculator. So I'm doing the first division example, 1.092 times 10 to the power 51 divided by 9.1 times 10 to the power 13. Close your parenthesis, press enter, and you can see that your answer is 1.2 times 10 to the power 37, which is the answer that we have here, 1.2 times 10 to the power 37. Okay, so now we can start dealing with rational exponents. And if we consider the form, and I mentioned this in chapter 4.1, the form n a to the power m, this must equal to a, n is the power, m is the root. To simplify expressions with rational exponents, convert the expression to a radical expression. So let's look at a couple of examples here. I've got -9 to the power half. So this is the square root of -9 to the power 1, which is the square root of -9, which is not a real number. Not a real number. -4 to the power half. So this is negative of 4 to the power half, which is the negative of the square root of 4 to the power 1, which is -2. Negative of -81 to the power 1 over 4. This is negative the fourth root of -81 to the power to the power 1, which is not a real number since the root is even. Since the root is even. Now, if the root is odd, remember we can find the cube root of it. So -27 to the power 1 over 3. This is negative the cube root of -27, which is the 27 to the power 1. 1 is the power, so this is negative of -3, which is +3. If I've got to convert 8 to the power 1 over 3, this is equal to -1 over 3. I make it a reciprocal, and when we make it a reciprocal, the sign changes. Okay? So making this a reciprocal makes it the sign on the power changes to +1 over 3. And this is the third root of 8 to the power 1, which is 1 over 2. -25 to the power -3 over 2. Again, we make it into a reciprocal, -25 over +3 to the power 2. So this is 1 over the square root of -25 to the power 3. But we cannot take the square root of a negative number. So this is not a real number. -16 to the power -half. Again, we make it into a reciprocal. It becomes 16 to the power +half. -1 over 16. The power is 1. The root is 2. So we're taking the square root of 16, which is 1 over 4 negative. Negative of -27 to the power -4 over 3. So 1 over, keep the negative sign here, negative 27 to the positive power 4 over 3. Negative 1 over the third root of negative 27 to the power 4. So this is negative, the third root of 27 is negative 3 to the power 4, which is negative 1 over negative 3 times negative 3 times negative 3 times negative 3 is positive 81. So this is 81 on the denominator. Please note that any of these problems can be done with your calculator. Again, make sure that you, when you're finished with the scientific notation, that you put the mode back to normal and press enter and then clear it. So if I wanted to find, say, negative 16 to the power negative 1 over 2, and I would, it was going to give me the answer in a decimal form, and I can probably ask for it in the fraction form by pressing math and then the fraction button, and it would give me the answer in the fraction form. So yeah, all of your problems could be done with the calculator, again, if you know what you're doing. Negative 25. I want to take this out of the complex mode for a minute. Hold on 1 second here. Then clear this. So if I'm answering, say, negative 25 to the power negative 3 divide 2, this is not a real number, so it will give me an error message and say non-real answers. Okay, which is this problem right here, where we say it's not a real number. Now, if we're I just wanted to give you a couple of rules here for exponents. I'm going to just list them here. X to the power negative n. If we write this as a reciprocal, it becomes x to the power positive n. And this rule also works backwards. X to the power negative n becomes x to the power positive n. The product rule says if we're multiplying x to the power m, x to the power n, we would add the exponents. The quotient rule says if we're dividing x to the power m over x to the power n, we would subtract the exponents. And note here that x cannot equal to 0 because we can't divide by 0, yes? The power rule says x to the power m times n is simply the product of m and n. Multiply the two. Anything to the 0 power is equal to 1. Anything to the 0 power is equal to 1. And one final rule here, this is a spin-off of the power rule for quotients. I'm sorry, the power rule, the product rule, says we can split up xy to the power n to give x to the power n times y to the power n. And as applied to quotients, x over y to the power n is x to the power n over y to the power n. Alternatively, if we have x over y to the power negative n, all we would do is flip over x and y and the power would change to positive. So let's look at a few problems related to this section. Example, x to the power 2 over 3 times x to the power 1 over 4. Since the bases are the same, we would simply add the powers, 2 over 3 plus 1 over 4, to give x to the power 11 over 12. Or if we're doing a subtraction, a division problem, we would subtract the powers, to give x to the power 1 over 10. Again, if you're not sure how to do fractions, you can always use your calculator. For example, if I wanted to add, say, negative 3 divided by 2 minus negative 8 divided by 5, make that a negative sign, and I would ask the calculator for a fraction answer by pressing math, fraction. Something is wrong. Let me go back to it. Okay, let's clear this and start over. Negative 3 divided by 2 minus negative 8 divided by 5. Math, enter, enter. And I get 1 over 10. And that's where this 1 over 10 came from on the power. Okay? So whatever method you use, if you also can do fractions from scratch by, making this x to the power negative 15 over 10 plus, not minus times minus becomes plus 8 over 5 is 16 over 10. So this is 16 over 10, which is x to the power 1 over 10. Okay, so hopefully you guys can manipulate your fractions. I'm not here to teach you that right now. X to the power 3 over 4 divided by x to the power 5 over 3. So this is x to the power 3 over 4 minus 5 over 3, which is x to the power 9 over 12 minus 20 over 12, which is x to the power negative 11 over 12, or 1 over x to the power positive 11 over 12 if we take the reciprocal. Be careful because this question could ask with either a negative or a positive power. Let's do a couple more examples here. So this is a multiply problem. X to the power negative 3 over 2 times x to the power 7 over 4. So this is x negative 3 over 2 plus 7 over 4, which is x to the power 3 negative 7 over 4 minus 3 over 2 is 1 over 4. Okay, so this 6 over 4 plus 7 over 4, so that's 1 over 4. And if we express this as a reciprocal, it could be or 1 over x to the power negative 1 over 4. Other types of problems, I'm going to do maybe 3 or 4 more examples. If I've got the 6th root of x times x, this has to be rewritten as powers this time. So there's x to the power 1 over 6 plus x to the power 1 over 2, which is x to the power 1 over 6 plus 1 over 2, which is x to the power 4 over 6, or x to the power 2 over 3. The 4th root of y over the 5th root of y. So y to the power 1 over 4 divided by y to the power 1 over 5, which is y 1 over 4 minus 1 over 5, y to the power 5 over 20 minus 4 over 20, or y to the power 1 over 20. I'm expecting that you guys can do the fractions. All right, now other types of problems. So here I've got y to the power 5 over 9, y to the power 2 over 9, minus 7y to the power 3 over 9. So you would distribute y to the power 2 over 9. That would give y to the power 5 over 9, y to the power 2 over 9, minus 7y to the power 5 over 9, y to the power 3 over 9. Then add your exponents. So this is all powers, the roots, all 9s here. So this is y to the power 7 over 9 minus 7. 5 plus 3 is 8 over 9. Oh, there's the 9 right there. And then if you're doing a problem such as this one, x to the power 1 over 4 plus 6, x to the power 1 over 4 plus 2. You would use FOIL here, first outside, inside, last. So F FOIL, first 1 over quarter times 1 over quarter. Outside, 2 times x to the power 1 quarter. Inside, 6 times x to the power 1 quarter. And last, 6 times 2. So 1 quarter plus 1 quarter is a half. 2x to the power quarter and 6x to the power quarter is 8x to the power 1 quarter plus 12. Finally, when factoring exponents, always factor out the lowest power. So if I have to factor 5x to the power negative 2 over 7 plus 2x to the power 6 over 7, I can see that negative 2 over 7 is the lowest power, so negative 2 over 7. So if I subtract x minus 2 over 7, x minus 2 over 7, I'm just left with 5 for this one. And then this would become x 6 over 7 minus negative 2 over 7, which is x to the power negative 2 over 7 5 plus 2 x, negative and negative become positive 8, so x to the power 8 over 7 in the factored form, 8 over 7. I can show you one more of these examples. 3x minus 3. Let's just put a line in between here. So if you guys were in class, then I would have been asking you to try this one. 4x to the power 5 over 2. So here I'm going to factor out 8x minus 3 over 2. That leaves me with 3 plus 4x to the power 5 over 2. And if I take away negative 3 over 2, it becomes plus 3 over 2. So x to the power negative 3 over 2. 3 plus 4x to the power 8 over 2. X to the power negative 3 over 2. 3 plus 4x to the power 4. Okay, and that concludes our lesson for chapter